So wave speed is calculated using this equation. This is the wave equation. Wave speed is like any speed, so it's measured in meters per second, like any speed. You know, they put a word in front of speed there, and then people get confused and forget the units. It's the same as any speed, meters per second. Frequency is measured in hertz, and wavelength is, again, they've put a word in front of a word that you know. So you know length, and you should know that length is measured in meters. So therefore wavelength is measured in meters. Now those on top of the symbols, so in brackets, sorry, I should say, so wave speed we use v, which is like velocity. Frequency f, that makes sense. Wavelength we use lambda, which is a Greek letter. So those are just symbols though. The actual units, which are the things you get marks for, I've gone through: meters per second, hertz, and meters. Okay, so you could put that into a triangle if you prefer to use the triangles. That's there's the triangle done for you. I'd cover up the thing on its own, which is wave speed, cover it up, and I put the other two in. So because it's frequency times wavelength, they have to go on the bottom of the triangle. That leaves room to put v back in. So just imagine put your thumb in front of the thing you're trying to calculate. So if I was asked to calculate wave speed v, I could put my thumb over v, and that would reveal f times lambda. Don't just write f times lambda, you must write v equals f times lambda. If you were asked to calculate frequency, I'd put my thumb in front of f, and that would reveal v over lambda. And then lambda would equal v over f, following the same logic. Okay, so I'd like you to have a go at these three questions. Sorry, these four questions, but I'm going to reveal the answers to you anyway. So that way you can just check that you've done it right. But I would like to see your working for these. So here it says a water wave has a frequency of 2 hertz and a wavelength of 0.3 meters. How fast is it moving? So you should realize they're asking for the speed of the wave, which is just v equals f times lambda. We're just using this equation. You're asked for wave speed. Wave speed is already the subject of the equation. It's on its own, in other words. So that equals frequency times wavelength. So you would just do 2 times 0.3. Nothing tricky there. You'd put the units in meters per second, and it should come out as 0.6 meters per second. But it's important that you get used to setting these out. So if I was writing it, I would read through that and I would write f equals 2, lambda equals 0.3, and then I write v equals question mark. So that's extracted the information from the question. Then I'd write the equation, v equals f times lambda. Underneath the f, I'd put 2, and underneath the lambda, I'd put 0.3. So then that would be 2 times 0.3 equals 0.6, and then make sure I get my units right. Okay, number 2 asks for the wavelength, so we do need to rearrange. Wavelength, as you can see on the bottom there, cover it up, and that would equal v divided by f. So v divided by f would be your 1 divided by 5, which is going to be 0.2, and then just check your units are correct. Meters. Nothing tricky so far. With number 3, speed of sound is 330 meters per second. That's something that, you know, is true value, so it's a common one to crop up that. And then this one where it says here's the sound his ear vibrates 660 times a second. So what they've done there, instead of saying the frequency equals, they've said the 660 vibrations per second. So it's a little trickier, just relying on you understanding what frequency is, number of oscillations per second, and then you can spot that, okay, so frequency is 660. Now the fourth one has standard form here. So hopefully you can use your calculator with that. If not, you could just send me an image of your calculator, because some of them have different buttons, and I could tell you which button to press to use this. But 6 times 10 to the minus 7 is the wavelength, and the frequency is 5 times 10 to the 14. So you're multiplying, there's no rearrangement needed there because you're after the speed, but you're multiplying 6 times 10 to the minus 7 by 5 times 10 to the 14. So You should get those two answers for the last two. Okay, so things you might come across in these. So what I'm going to ask you to do is show me you're working for those 4 questions, but then there'll be a worksheet attached to this, and I'd like you to do those, please, with the full working for every single question. So things you might come across when you're doing that is standard form, first of all. So that's what we've just seen, times 10 to the power of something. So a simple example, I know you will have done it in maths at some point, but 3.5 times 10 to the 3 is the same as 3,500. So times 10 to the 3, the little number above the 10 there tells us how many times we need to move the decimal point. Times 10 to a positive value, the decimal point goes to the right, making this number bigger. So if I moved it once, 350, and 3 times, 3,500. This number is a common number you're going to come across, 3.00 times 10 to the 8. That's the speed of light. And you might have spotted, if you research the electromagnetic spectrum, that light is just part of a family of 7 waves, gamma all the way through to radio, and they all travel at the same speed. So gamma rays travel at 300 million meters per second, as does X-rays, radio waves, infrared, ultraviolet, visible light. So you come across that quite a bit. They could even throw a trick question and say, it's not a trick question, but they might say, you might, question part A might get you to work out the speed of light, and then it might ask you about microwaves. So it's relying on you knowing that it is the same speed. You can take that speed and put it in to part B. Prefixes is the other one. So you can look at prefixes, but kilo or kilo is times 1,000. It goes in 3 zeros. And you see the next one up, mega, is times 1,000,000, which is 6 zeros. So 10 kilometers, I add 3 zeros there, becomes 10,000 meters. So a megameter would be 1,000,000 meters. So kilo, mega, giga, tera, peta. Now the reason that that's common is because your frequencies tend to be very large numbers, so you might get gigahertz, and the wavelengths are very often very small numbers, so you might get micrometers. So milli, micro, nano, pico, femto is going the other way down. So milli is divided by 1,000, micro is divided by 1,000,000, nano is divided by 1,000,000,000. Okay, so if you've struggled with them, I can support you more with that and spend some time with you. It's one of these things that some people think it's very easy, because you've done it in maths and it's clicked for you, and that's great. But there'll be loads of people that are still struggling with prefixes in standard form, and I'd implore you just to drop me an email saying, sir, I hate standard form, I hate prefixes, what's going on? And then I can spend some time emailing you to try and find out what it is you don't get, and try and get you to get it to click in your head. Because once it clicks, it'll be a skill that will stay with you forever. Okay.